Section 1.9, inequalities. We are only going to be discussing inequalities in this section. We will not be looking at absolute value, which is part of this section, but we are omitting it. Okay, the first thing we need to know how to do is write something in what's called interval notation. So if you have an open interval, that's going to look like an actual ordered pair, but it's not an ordered pair. So it's just something you have to understand when you're looking at the directions. Be able to, if it is asking you for the answer in interval notation, to express it like this. So what is this? Why would you have something like this? Well, let's look at this example. Okay. Let's say you solved an inequality and you ended up with this compound solution. So x is greater than -2 and less than 1. All that means is, when you rewrite this from inequality notation form to interval notation form, is if you have a greater than, or if you had a less than inequality symbol, you're going to be using parentheses. Okay? On the graph, you can use parentheses as well, or you can use an unshaded open circle. So what's a closed interval mean then? Closed interval means you include the or equal to component. So here's an example of that. If you have this compound inequality, x is greater than or equal to -1 and less than or equal to 2, that would look like this in interval notation form. So if the or equal to component is there, use brackets. If it's not there, use parentheses. Now, graphically, you could use brackets on the number line, or you could use a shaded in solid circle. Either way, doesn't matter. All right, here's an example of one that's greater than and also a less than or equal to. So that would look like that. And then one more, okay? So those are for finite intervals, all right? Those are for finite intervals. Now let's take a look at infinite intervals. So for infinite intervals, you're going to have the infinity or negative infinity symbol as a part of these, interval notations. Okay, so this would be like if it's just greater than a real number a, all the way to infinity. So it goes forever to the right. All right, let's go ahead and do the same thing here with respect to infinite intervals as we did with finite intervals. Okay, so the first example I'm going to give you is if you have this for your solution. This is the inequality solution you came up with. X is greater than 2. If the directions state to express your solution in interval notation form, then this x greater than 2 would translate into this open interval, okay? So again, if it's greater than, you're going to use parentheses. So it's starting just after 2, and it's going forever to the right. Notice the inequality symbol is pointing that way. That means it's going to go to infinity. You always use the parentheses when using infinity. All right, so if it's going to infinity, use parentheses. If it's going to negative infinity, use parentheses. All right, never ever will you use brackets to indicate something's going to infinity or negative infinity. That doesn't make any sense because brackets indicate inclusiveness. And this is non-inclusiveness. You can't count this high. It just means it goes on forever. It's symbolic. So you could use parentheses on the number line or just an open circle like that. Here's an example of another one, x greater than or equal to -1. So open bracket at -1. It is able to be equal to -1 in this particular example, and it goes forever to the right to infinity. So this would be a solid shaded in circle just like that. All right. A couple more examples. Again, if it's going to the left, less than, okay, that means you're going to open with negative infinity. All right, parentheses is how you have to start it because you can't cap negative infinity or infinity. Okay, so let's get into some actual examples here in which we will solve an inequality and then express our answer in interval notation form. All right, so number one, we're going to isolate the x. So you're going to handle these inequalities exactly, well, not like that. You're going to handle these inequalities exactly like you would handle solving an equation, with one exception. Do you remember what the exception is? The exception is if you have to multiply or divide by a negative to isolate the variable, you do what? You flip the inequality symbol. Okay? My wrist doesn't bend all the way around. So anyway, for the most part, the properties of equality are still in play here. So we are not dividing by a negative here to get x alone. Therefore, the inequality symbol stays the same. We end up with x is less than negative 2. So at this point, not only should you be able to do this, based upon your answer, let's just make this quick. It's just less than, that means open circle. We know we're going to the left because it's less than. And so this is an infinite interval. What does this look like then in interval notation form? Well, it's going forever to the left, so you open with negative infinity. And then you're going to negative 2, close parentheses. This just means it goes almost all the way to negative 2, but it does not include negative 2. So you should be able to come up with all three of these things. All right, number 2. Now I need to isolate x by dividing both sides by a negative 3. Because we just divided both sides by a negative 3, that means you do what? You flip the inequality symbol. So your final solution here is x is less than or equal to 4. Now you should be able to graph this on a number line. So you put the 4 on there, you shade in your circle, or you can use the bracket if you wish. I like doing it this way. And x is less than again, which means it's going to point to the left. So there's the graphical solution. And then the last thing we got to do is the what? The interval notation for this. So this is going forever to the left. So we're going to start with negative infinity again. Then we go all the way, and now we do include the 4. So it's closed bracket. All right. That takes care of the first 2 examples.